Well, dear students, this video we are going to talk about discounts and raises. In the previous video, we talked about percentages, we talked about relations between two variables, y and x. Also, we are going to talk about relations in this part about discounts and raises. But before, let's explain a little bit about discounts. You know, discounts are used in stores. They usually make discounts or sales or reduction of prices, so that's related to subtraction. Things are going to be less, while raises is related to addition. Things are going to be more. And here we start with the first activity. A store announces 40% discount on all of its items. Let Y represent the new price after the discount, and let X represent its old price before the discount. So X is going to the actual price and Y is going to the new price after the discount. So the first question is to write Y in terms of X. That's what we call the linear relation between Y and X, or the algebraic expression between Y and X. And here we go with the solution. Note that because we are talking about a discount, then all what we care about is that minus. So we usually write this sentence, we usually translate it mathematically into y equals a parenthesis including 1 minus 40% means 40 over 100, as we mentioned previously, 40 over 100 into x. That means if I'm going to think in another way, if the discount is 40%, then the percentage of payment is 100 minus 40, which is 60%. And all what I care about is what am I going to pay. So that's what I care about, the payment, the percentage of payment, and not that of the discount. But the percentage of the discount tells me the percentage of the payment. So I can directly say that the new price is going to be just 60% of the old price. So 60% of the old price X. I can't write just 60%. I have to write 60% of something. Of something means multiplied by this something, and by this I'm going to get that Y equals 0.6 X. So as you see here, if I don't want to make the subtraction before, I can write it that way. Y equals 1. I usually represent the total decimal by 1 minus 40 over 100, and this is gonna be 0.4, and the result will be, as you see here, 0.6 and here 0.6. So either you write it that way, either you are going to calculate the payment, the percentage of the payment, or you write it that way. I prefer that way. That's taking fewer time, and then I'm going to use this relation. So Y, which is the new price, is equal to 1 going to the total minus 40 over 100 going to the percentage given, and you have to write into X, which is multiplied by X, which means of the initial price X. And this is what we call the linear relation between Y and X, and this is what we are going to care about. Now, let's continue. When do we use this relation? Let's make another example, and then we are going to know how to use this relation. A company decides a 10% raise on the salaries of its employees. Okay, so there is a raise here, then the raise goes to the addition. Denote by X the old salary of each employee, and by Y the new salary of after the raise. So X goes to the old salary and Y goes to the new salary. Express Y in terms of X. Let's think a little bit. It's going to be like this, but there's something a little different. What is it? Let's see. We have to write Y equals 1 plus 10 over 100 plus, notice here is minus because there is a discount. So a discount means a minus sign, a raise means a plus sign. So 1 plus 10 over 100. Where does 10 over 100 come from? It's from the given percentage of raise, which is 10%, then 1 plus 10 over 100 of the initial salary, which is X. And thus, I'm going to get 1.1 because this is 0.1. And because I'm adding 1, then I will get 1.1. So notice, the relation when there is a reduction or a discount or a sale is going to be y equals 0 point something. But when there is a raise or a gain or any increase, this will be 1.1. 1 point something, 1.2, 1.05, 1 point whatever. So it's just 1 point and not 0 point. So that's to make sure of your relation. So again, if there is a discount, the relation will be y equals 0 point something x. And if there is a raise or an increase, the relation will be y equals 1 point something x. And let's continue to get more ideas. Here is a bonus. Also, I'm going to let you think of it. An item costs $100. It is submitted to 3 successive discounts of 20% each. I want you to find its final price and to send me the answer later, inshallah. Here are important words that you have to know. If there is the word discount or sale or reduction or sometimes, let's write it here, or sometimes decrease, then you are going to apply this rule, y equals 1 minus the given percentage over 100 into x. If there are these words that are gain or raise or TVA or VAT, you know, in the supermarkets, they usually add that value. Or if there is the word increase, then you are going to apply this rule, y for the new, x for the old, and in the parentheses you write 1 plus and not minus the given percentage over 100 into the old given value. Okay, now let's go to see more examples. Training exercises. The old price of an item was $1,035. Okay, its new price becomes $828. So notice that the old price was this, its new price becomes this. Then surely there is a discount, not a raise. There is a discount because the new price is less than the actual one or the original one. Find the price of that discount. Find the percentage, of the discount. Now to find the percentage of the discount, what should I do first? Think a little bit. What should we do to find the percentage? First of all, we need to find the actual discount, which is this. By subtracting the initial price minus the new price, we will get the amount of the discount and not the percentage. Now how to find the percentage? We put the total, which was this. In this number, 1035, there was $207 discount. So what about 100? That's what we are going to do. Cross multiplying, we will get that the discount is 20%. So the discount that occurs here is 20%. Checking, let's make a check. Let's make sure if the discount is truly 20%. So this is the new price. It must be 1 minus, because we have a discount, that percentage by 100 into multiplied by the initial price. So let's make sure, yes, it is. Use your calculators and you are going to get the same answer. So again, this is the new price after the discount, this is the old price, and this is how to represent the discount. 1 minus the percentage of discount we got here. Another example. A bag weighs 3 kilograms. When filled with stuff, its weight becomes 4.5 kilograms. So you notice that its weight increases by 1.5 kilograms. Find the percentage of the gained weight. So first of all, I have to subtract to get the value of the increase. So 4.5 minus 3 is 1.5. Now in the initial weight 3, the gain was 1.5. So what about 100? Then the percentage of the gain is 50% of the weight of the bag. It's true, because the bag's weight is 3 kilograms. 50% of its weight is the half of 3, which is 1.5. Now 3 plus 1.5, so this goes to 50% of the initial weight, which is 3. So it is 50% of 3 kilograms, means half of 3 kilograms, which is 1.5, plus the initial weight of the bag, then we will definitely get 4.5. Okay, so these are training exercises to let you find the percentage of discount and here the percentage of increase or raise. And that's the checking. 1 plus 50 over 100, because we have raised, into 3 into the initial weight of the bag, and we will get 4.5.